And we are live, hopefully. I think. Yeah, and we are live. Okay. So, I'm gonna use this time until people have tuned in, I guess, to explain to the VOD what we are gonna be doing today. Yeah, okay, so I haven't worked too much on type classes since the last stream. I got kind of distracted with other things. Yeah, I did implement evidence passing, so like you can already see that here, I guess. So we can compile type classes mostly. There's just one issue, and that's this thing we did last time, where in order to match type classes, we would like close close all unification variables in the type and then try to unify with that and like catch unification errors. That's not going to work because if we ever have... Okay, so wait, I'm gonna need to draw that out somewhere. Actually, I have a ton of notes down here. So yeah, the issue is roughly this. If we ever have local assumptions, like mostly because of GADTs, probably, then we might have a constraint like, let's say, a equals int, where a is a golem, right? So a is an unification variable, and no, it's not a unification variable. A is a variable that was introduced by checking against a type with a polymorphic type variable, right? And so right now this constraint would be unsolvable and we could just throw an error. But if we had a local assumption of the shape a equals int, then this would actually be solvable and we would just need the assumption there. And so what's gonna happen is that when we introduce those, unification might not fail, but might create new unification constraints. If we try to solve list a equals list of int, then this is... no, it's not going to throw an error, and instead it's just going to create a new wanted a equals int. And that's an issue, because we don't want to be doing that when matching against type classes. We just want to see if types match. We don't want to bind anything or create new constraints. Yeah, and so that's kind of problematic. And so we're going to have to throw that entire logic out and rewrite it from scratch. Yeah, I had some fun ideas about like using a try and like like a prefix tree where we would have like basically EQ anything and then or actually not EQ, like any other class with two parameters, and we would have like C of int anything, and then we would have over here C of bool anything, maybe something like that. But I'm not sure how to deal with ambiguity here, because you might have like an instance like C of int bool, C of int a for all a, and you might have an instance for all a C of a bool, and then like trying to match or trying to create a constraint C int bool would be ambiguous, and I don't know how to do that in a try. So we're not going to do that, we're just going to linearly match for now. And I'm going to try to figure this out, hopefully, at some point. So yeah, so we are going to throw most of this out, or at least this log traversal thing. And instead we're going to check compatibility. So how do we do that? I guess it's just like unification without actually binding anything, which is going to be a bit problematic around row polymorphism, but we'll get to that, I guess. So yeah, I guess we can just try that. Do we need to keep track of the unification state? I don't think we do. No, that's just deferred constraints, right? Yeah. We don't care about that, I hope. Yeah, and so we're gonna check a given want constraint against a given constraint. Oh, we're also gonna need to worry about ambiguity though. Well, let's leave that for later. Yeah, so I guess it's just... What's the given constraint like? And what are we doing here anyway? Arguments are actually instantiating and locking things. And we need the evidence. Do we have the... Yeah, right, we have the evidence in a given constraint, right? Okay. It's kind of... Yeah, sure, let's look like this. So given constraints look... should we split that up? Hey! Yep, okay, man. Hi, Mina. Yep, that's... yeah, that's the camera. And we are doing... you probably didn't see that, but we are doing type classes. And yeah, I had this thing last stream where the idea was basically if we match a wanted constraint, so class constraint that we are trying to solve for, we would basically iterate through every given constraint and try to unify them, and if that fails, then we'd move on to the next one. But we can't do that because unification might create additional unification constraints soon. It doesn't right now, but it might soon once we do GADTs. And so we're gonna have to throw that out and rewrite that from scratch. Yeah, and that's what I'm trying to do right now. So I guess this given constraint shouldn't actually be if any given, should just be a class given, so just a location and a I guess I'll call it given constraint, but it's gonna be a class constraint, not any kind of given constraint, just a given class constraint. And we also need the evidence to fill in, which is, no wait, the evidence to, no, we need the evidence source, because the wanted constraint contains the evidence to fill in. Yeah, something like that. And so yeah, let's throw that out because that's completely irrelevant now. Wanted is make... Oh, right, yeah, that's just a class constraint. Where's the... Oh, there's the evidence target. Yeah, so we also need to split the wanted constraint. And in... I guess we should split up the location. And that's the evidence target. Okay. So where was I? Right. So I guess, yeah, this we could still do it here. Then instead of instantiating and locking, yeah, instantiating is a pretty bad idea. We are going, actually, wait, this replaces type variables? What did I do here? This replaces type variables with unification variables? Why? What? Why did I do that? It doesn't make sense. Like, this need to be... wait, God, I need to understand what I did last time. Because type variables need to be part of the instance head. Like, the instance has to look like for all a EQA, something like that. EQ list of A, I guess makes more sense. Right. So I'm not sure what I did here. Let's just not worry about that. Oh, right, that's going through given.arguments. I guess that makes sense somewhere. Yeah, and then instead of this one, we are gonna match this valid instance of, and that's not environment given, yeah, given location. Oh god. Oh wow, that one would have actually broken the location unwanted. Whoops. Good thing I didn't actually do that. Good thing I changed that, I guess. Takes the given, that takes the source. No. Wait, what? No, that takes the evidence target. No, evidence source, but yeah, this one. Takes the evidence source. Target location and the no, not the target, the wanted location and the wanted and the evidence target. Perfect, and that either returns true or returns false, in which case we move on. Okay, perfect. Right, that's a lot of parameters. Okay, so we're gonna, I guess we can just match on the target directly. Wait, no, actually, those are, what do class constraints look like again? Variables, class names, arguments, right, so we need to, I guess we don't, well, we do need to, like, alpha normalize variables. Oh, that's annoying. I guess we can just use the same scolums for both types. Yeah, that's fine, actually. No, that's perfect, actually. No, wait, never mind, that's great. Because what we're looking for is, like, we're not gonna bind any unification variables, because that, like, we're just matching against the constraint. We need an exact match, otherwise we might pick the wrong one. We might actually want to pick a different match. Yeah, so we are actually gonna scolumize both constraints, I guess. So I guess I think we can use the same traversal for that. No, we can't, because we need to use the same. No, you can. We can. We just need to use the same unification variables, but we can parameterize it over that. No, scolums, not unification variables. Okay, so can we? No, we can't. No, wait. That's no. Oh, I'm an idiot. The wanted constraint cannot contain any variables. That's weirdly modeled, but yeah, that one can't have any. So we just need to scolumize the given constraint. So I guess we need to rewrite that traversal I just deleted. Yeah, so that's a unit traversal. What did I do wrong here? Oh, right. In. Let in always. That's kind of annoying. Just because OCaml doesn't have layout. Okay, so we are gonna find the variables columns. So we're gonna take the given variables. For each of those, pair that up with a fresh column. Yeah, this one. Okay, so that gives us a map of fresh columns for each variable. That's perfect. And then we're gonna override which one child. Wait, yeah, we need to override types, of course. That's not how traversal works. And yeah, we don't need to return anything. We just match on the type. Does that? Wait, did I do that correctly? Does that follow unification variables? I think it does. That's not types traverse type. I think that it does not follow unification variables. Oh, it does. It just does manually. Okay, that's fine. Yeah, that's perfect. Why is that? Oh, that's meta programming magic. That's fine. That's error doesn't. It's not actually a warning. That's just because that section of the code is copied to multiple instances, and so one of those is in one of those the match would be redundant, but not in the other one, so I can remove it. But yeah, that's a different issue. Okay, so we are gonna replace variables and variable rows. I think, are we gonna replace variable rows? Yeah, we are. Our rows are gonna be complicated. And that's a variance. Okay, yeah, so we are gonna replace variables. I guess actually we should throw an error if that's not one of... Yeah, if there's a stray unification variable, you need to throw an error, but that's fine. Or we need to panic, I guess. And we need to begin and end because the common syntax is not great. Yeah, in that case, oh wait, we don't actually want to use a golem there. We want to use just golem raw. We need to, yeah, then type ref. No, wait, that's the wrong one. I don't have a raw fresh golem thing. No, that's because that's just a unique. No, that's user level. Yeah. Because we need to insert that into the row, and the row only stores the unique and the level and things directly, and not a full type. Right, so it's just unique. If that level and name. Okay. So in that case, that's a unique level, if I can spell it correctly, name, and we stack all of those in as golem. Oh, we need to change the function, of course. That's the type and the unit, right? Because of the traversal. And this is gonna throw, or gonna panic. I should add a location. Okay, perfect. And I guess we can just repeat that for the other ones. Yeah. That's some Haskell again, so I mess up the syntax every time. That's constructors, unique level name. No, that's wrong. Two arguments. Oh, so that's trooper? Is that it? It's not a trooper. Name. Oh, of course. No, that's correct. Yeah, and same one for variants. No, those are not constructors, those are fields. So this returns a variant, colon, all the constructors, and the actual colon. Okay, perfect. Right. So we have the colon advisor, we can apply that on the given constraint. Actually, do we? Scholemize. Oh, we might not want to scholemize those. Actually, no, let's not do that. Okay, so let's yeah, no, let's not do that. That was dumb. Let's just throw that out again because it's actually much. Yeah, that would be a terrible idea. We should actually keep those as variables because then we can know which ones are wildcards and which ones are not. And we don't need to bind them, so we don't need to like unify anything. But yeah, we need them to be separate from actual columns. Yeah, okay, so let's not do that. Okay, so we're gonna match the types. And we're gonna need like a subtyping thing, but that's fine. I guess technically this is sort of like a subtyping relation. Oh, yeah. So we're gonna match the given type. Right, because now we can say if this is a variable, then we don't care. And we can just return. And actually, do we want to return or do we want to throw an exception? It's like a short circuiting, because that might be faster in OCaml. I don't know, we'll see. But if it's a type where we... Oh god, now I'm gonna have to enumerate every single one of those types. Okay. So, if this is a for all, then that's weird. Is that possible? Yeah, I guess it is. I'm not sure about that one. function, that's easy. Constraints are also weird. Is that possible? I'm not sure. Wait, can this create... Is that possible? Can they be a... Yeah, of course they can. Yeah, because I rank types. Yeah, type variables are the easy case. Oh no, wait, we do need to keep track of type variable substitutions. Ah, that's annoying. Because you might have the same variable at multiple places. So we need to track our own substitution. I guess we can just use unification variables. No, let's not do that. Let's not do that. Let's do a map. Right, so that's keep track of the substitutions and reference. So that's gonna be an empty name map initially. Yeah, right. So in that case, if we have a type variable, we're gonna fill it in. With what? With the wanted type. Is that correct? Yeah, that's correct. That's the correct order. What's the error here? What's expected of type int? Where did int come from? What? Where did the return type int come from now? You wanted type substitutions? Oh, because of it's just yeah. Oh, common language server is just confused. Okay, so type constructors are easy. Let's do that once the LSP is ready. Aliases shouldn't... Oh wait, I need to... it's called normalize unit, right? So that one should be impossible. No, it shouldn't. What? I'm not following... I guess I'm not following type constructors, that makes sense. Type aliases. Yeah, okay. Because we could technically remove type aliases, but we should keep them for as long as possible for error messages. Okay, let's worry about that later. And that one should be impossible. Or should it? Actually, it might be possible. But we need to... Yeah, that one is possible. Because we might have a local assumption somewhere that mentions the unification variable. So we just need to treat it opaquely. Yeah, that's fine. And then a scolon. Number, yeah, these are just concrete cases, so extremely easy. Hopefully. Yeah, that's just... Yeah, okay, let's actually fill this in, that's getting kind of boring. Yeah, so I'm not sure what to do here, but this one is easy. So let's go with the function. We can... yeah, the other one also needs to be a function. And yeah, let's throw an exception. Can you declare local exceptions in a comma? Is that a thing? Is that? Compile? What's that? It might actually compile. Oh, that actually works. Oh, that's cool. Didn't know you could do that. You can just declare local exceptions in kernel. Oh, it's really cool. Okay, we can check. Yeah, right. So if the things match, then we are gonna we're gonna recurse. So we're gonna iterate2. Oh, actually, and we need to check the argument length. No, it's not if, that's called when. Oops. Then we can iterate2, so we can zip with arguments with just match type substitution, not chance. That doesn't really make sense. What's this? Okay, so I can just map through those. Then do the same on the result. And if all of those match, then we're set. Okay. Yeah. What's going on here? I think it's just confused. And if we have anything else, we can raise does not match. I guess I'm gonna need to fill those in. So my language server actually works again. Sure, let's fill this in. Yeah, but most of those are just boilerplate. Like references, lists, promises, tuples, those all just recurse on the arguments. It would be kind of nice to have those as built-in types and not as like language, no, as like well, not quite user-defined types, but types that are just like regular type constructors and not like language syntax like here. Yeah, but not sure about that. Oh god, records are kind of annoying. Yeah, records are gonna be something. And variance are basically just like records with the sum type equivalent. And this one shouldn't exist anymore. Yeah, that's a void. I can just oh, right. Yeah, that's essentially a void. So it's just absurd void. And why are you still confused? Because I forgot a type parameter, right. Why is the language server confused? And that needs to be recursive, because of course it does. And I misspelled result 2. Great. What's... Oh, right, and that needs to carry substitutions. I'm not sure why my language server is having issues right now. And that's called substitution. Class constraint was expected of location. What wanted location is not a class constraint. Huh? What happened there? Wanted location is definitely not a class constraint. It's a location. Did I mess up the order parameters? Yeah, of course I did. Oh. Sure. Now it compiles, but my language server is still not back. What's wrong here? There you go. That's better. Okay. Perfect. So, guess we can do a whole bunch of recursive boilerplate again. Ooh. Oh, yeah, no, constraints are fine. Constraints are like functions. But I really don't know what to do with for alls. Because I don't think... No, actually, yeah, no. You could have for alls and constraints. You could have something like EQ for all A. Well, no, you couldn't have EQ for all A.A, right? Because that one needs to be like a row type, without a total for all. But you could have a higher rank type, like maybe for all A, arrow number or something. I think that's valid. Yeah, that should be valid. I'm not sure what to do in that case. Can you have a given for that? I guess technically you can. That's strange. I'm not sure what to do there. Maybe just reject that? No, I don't know. So if you wanted is also a constraint. And we need to unify constraints manually and otherwise. We do class constraints. Wait, no, those are types. I'm an idiot. Those are types. We can just unify them. Those are not real class constraints. They're just types of kind constraint, which is different. And so we just unify those. Oh, match those. Yep, and that should be constraints. What's wrong here? I think this. Oh, forgot an end. Yeah, now it's exhaustive. Perfect. So type variables, add a new cell. Oh, no, that's wrong. Type variables have to look into the substitution first. And if that is not substituted yet, we substitute it, and if it is, then we raise, we match against that. Right. And so this behaves basically exactly like regular unification. Substitution. Can't spell today apparently. And that's... Wait, no, that's, no. We match substituted against wanted type. Right. That's all. Okay, and we continue on. honestly expected this one to be a bit more exciting, but you'll have to bear with me, I guess. It's important that we use name.equal and not equals, because this one is constant time. Equals would traverse the strings and be linear time. So yeah, very important, very typical OCaml footgun. What's going on with my OCaml language server? It's still running though. Not sure what that's about. Okay, right. And yeah, the length has to be the same, because otherwise, yeah, that wouldn't be possible if the names are equal. So we don't need to check manually if the length matches. So just match the substitution and continue on. Perfect, okay. Alias, follows the alias. So carrying, actually I don't need to carry the substitution. I'm an idiot, I can just put that up here, because it's mutable anyway. And now this entire code is a lot nicer. That's good. Okay. Yeah, so that one just gets rid of the alias, because we're not producing any error messages anyway, so we don't care. Right, unification variables. I guess just need to be treated like scodums, so compared for, no wait. Yeah, no, unification variables need to be checked for equality. Because we might have the same unification variable in both, and that's fine, but everything else is not. Right, so in that case, we do nothing. And otherwise, does not match. It's still called when. Okay, quick. Right, scodum, same deal. I wonder if I could use a traversal here. I don't think I could. No, I can't. I can't match different types with a traversal. Though I might be able to write one that works like that. Yeah. And it's still called when, even though I messed it up every single time. Yeah, so this step is basically what we did last time with closing the constraint. Yeah, but we can't do that. So we need to do it differently. Woo. Then exactly the same deal. Plural and string and sections. Perfect. And more recursive boilerplate. was actually gonna do, well, I was hoping to do typeless entailment today. We'll see if we get to that even. That's an array, right? Yeah. And it's still called when. And those are also all because boilerplate, but we're almost done. And actually we can replace that. We can't leave it off, but we can replace it with a refutation case. Sure, kinda. Sure. Haskell could have figured that out. Just saying. Not saying anything about Haskell versus Akame here, but Haskell could have figured out that we don't need that case at all. We can copy the exact thing for references and promises. Not refine variant for ref. And for promises. And I have no idea what to do for records and variants, so let's skip those for now. Okay. Alright, I don't actually need that. So substitutions should take care of themselves. They can match types. And so I just need to match, yeah, this should have the same name. Yeah, right. It's a list of types, right? Yeah. Types, given constraints, and wanted constraint arguments. And if that just returns, then return true, I think. Return true. And if that fails with a does not match exception, then return false. And alright, I still didn't. Actually, no, this one isn't gonna worry about ambiguity. This one needs to worry about ambiguity. Right, and that should at least partially compile. It does not. Oh, right. Oh, oh no, it does. Okay, cool. Cool. So that should be fine now. And yeah, we just need to do error reporting. How? That's okay. Right. So when the constraint server is done, it might, yeah, it probably exits because it can't make progress anymore, and so we need to produce errors from any residual constraints, but I'm not entirely sure how to do that. Let's try something. Yeah. So residuals to errors is going to take a list of constraints and gonna return a list of type errors, and I absolutely do not have the infrastructure in place to actually do that. Yeah, okay, I guess I have to do it. So, it's gonna take a list because it might like merge constraints together or something like that. Or decide that some constraints shouldn't emit errors because of other constraints or something like that. Actually, maybe some constraints are fine even. Well, maybe not that one, but the rest. With the deferred constraints. No, no, unified state deferred constraints. Oh right, that's just a reference. Just need to dereference that. Right, okay. So we got our residual constraints. And we can turn that into list of type errors, and if we didn't, then I guess we just return, and if we did, I'm not sure what to do there yet. That's a difference list, so turn that into an actual list, and there. Perfect. Hi. Yeah, we're doing type classes. So yeah, you just missed the most boring part I've ever, one of the most boring functions I've ever written. So this is just like unification without the interesting bit, because if we match a type class instance, we don't want to bind any unification variables, because that might introduce ambiguity and we might want to actually match a different instance, but we already committed to this one and that's problematic. Yeah, so this is just recursively traversing every single type, and that's annoying. But now we're actually getting onto the interesting bit. Yeah, so the thing it currently fails with is here. If the constraint solver stopped making progress, hi Gabby, then we're gonna, we're either gonna return because we're done, we have solved all constraints, or we have a list of residual constraints that actually create a list of type errors, that we need to report as type errors. Like if we get, well actually, yeah, if we get something like number equals string or something, that's an unsolvable constraint, and so we need to emit a type error for that. So yeah, I don't really have the infrastructure for that in place, because right now this one just throws an exception on type error, and so it just returns one type error, and so all the pretty printing logic always assumes there's only one type error, but now we actually need to return more than one, and I'm gonna have to figure out how to do that. Okay, so but yeah, let's do error reporting first, I guess. So for now we can probably just yeah, we can just map over that, because I don't think we have anything fancy yet where we can like merge constraints together or anything like that. But that will probably come later. Okay. So what kinds of constraints do we have? So yeah, unification constraints are the easy ones, but I really want to tag those with like additional metadata soon. I think the left one's the expected, I hope I got that one correct. And I don't care about the environment. Because, like unification constraints are terrible error messages. Like just unable to unify type A and B is a terrible error message, and there are so many of those. And like we could track so much more metadata here, but not yet. Wait, no, that needs to be a type. I guess it needs to track the location for type as well. And something's wrong. Okay, I just messed something up because this is not valid occur. That? Yeah, that's not okay. What did I do wrong? Did I No. Oh, that's a tuple and a context. Oh god, I forgot about that. Ah, that's annoying. Oh no. Yeah, so I just lost the entire context. Okay, so for context, how this worked for now is or until now is that unification would track context about like where the unification originated from. So if you have something like list int equals list bool, then the error message you want to get is something like couldn't match int equals bool. But you also want to try you also want to add while trying to match list int equals list bool, and that was the context. But we're not keeping track of that anymore, and that's annoying. I guess we can just stuff that into the unify constant. Okay, let's worry about that later. I think it's optional, right? So I can just it's not nothing. I'm writing a camel, not Haskell. So I guess I can just put it none there for now. Ah, that's so annoying. Yeah, okay. What's wrong? That's... God, it feels like I can't write a camel today. I've written too much Haskell lately. Okay, so unify is easy. Unwrap. Oh, unwrap constraints. No, those are also easy. It's just the environment. Because I have an error message for that. I just don't remember what it's called. Cannot unwrap. That's none. That just takes the type. Okay, cool. Right. Unwrap constraints, program argument constraints. That one has a very similar one. Okay, I guess this reporting error messages part is actually easier than I expected. As long as I can remember what that's called, non-program argument. God, I should really standardize those names. Those are not the ones that are reported to programmers, at least. Those are only the internal variant names. So that's my justification. Oh, refine variant constraints should not stick around, I think. No, those... Oh, they might... Can they? I'm gonna pretend they can't stick around, and if I'm proven wrong, well, then I guess I'm gonna have to figure out what to write there. Because, so I guess I should give some context here. Refine variant constraints are actually kind of complicated, because they're part of a really cool feature for those where if you have all variants are polymorphic variants. So if you have something like a function that matches on a type, and that says if it's A, then I don't know, return something, and if it's anything else, then it does something else with that. And if you say X has type A or B, let's say just A or B, and returns anything, then in this case here, Y will only have type B, right? It knows that Y can't be an A. Actually, the language server would show me that if I didn't have type classes in the same module, because it doesn't know about those yet. Why is that type? What's... Oh, match X, of course. So if I do that, then and remove that, then yeah, right. You can see Y has type B, and that's what refine variant constraints are for. So here in this case, the variant has type A or B, and after this branch, it's only has type B, so this is the actual type here is a fresh unification variable with an unwrapped constraint that looks something like a refined variant constraint that looks something like refined variant. Say this one has type, I don't know, alpha, or not. Then this is like refined variant AB, A, alpha, right? And so that means alpha will be bound to this type without A once all the types are actually known and the constraint solver has progressed far enough for those. Yeah, so that's what refined variance constraints are. And I don't think those should be able to stick around. They might if the type on the left is like ambiguous. I don't know, I'm just gonna panic. Yeah, and interpolatable, it's exactly like those. And so I already have an error message ready for that. Perfect. And which one am I missing? Wanted. Yeah, right. And I think I also have an error message for that. Do I? Missing instance, right. Okay, so that was actually way easier than I thought. What's wrong? Inline record. Oh, because that was more than the actual constraint. Do I need to keep track of any of that? I don't need that, I don't need that. I don't need the givens, and I do need the location. Right, okay, cool. So now this should produce a list of type errors, even though it doesn't actually have a way to print those yet. Oh, why does that? Oh, right, because I have a... No, wait, what? Why? Oh, because it didn't actually throw any type errors. So that's why it compiled. Right. Okay, so this... What's type error here anyway? I'm not sure. Yeah, I know, let's just return that. How did I return those anyway? Right, so it has a list of type errors. And so I guess it can just... I guess it should just return okay type errors. It's not... Wait. Oh, right, unit. In that case... no, wait, that's exactly the wrong order. Well, in that case, just okay unit. So I can just return new result, sure. Why is this expected to have type unit? Because this is expected to have type unit, that's why. And this is gonna be a unit. No, it's not. Let's put unit in the comma. Or type list result, and I guess I'm just gonna have to deal with that upstream. This does not have type unit. Oh, right. Unit. Oh, location. Yeah, right. I need to keep track of locations because type error is the only error in the entire compiler where I didn't store the locations in the constructors, but I kept them separately in the exception. And now it's also the only one where that's not relevant anymore. And I should have stored them in the constructors. But yeah, okay, sure. And those are errors. This can still do that. It's the close variance, at least for the language server. Wait, how does... Oh, no. Something's wrong. Oh, something is very wrong here. Why does this one... Oh. No, it's not, actually. Is it? No, that's fine. That's fine. Because, yeah, this amazing function name check exhaustiveness and close variance in expressions does... I love that name. Actually might mutate some unification variables again. Yeah, okay, but that's fine, because it might... yeah, it runs after the constraint server, so it can't produce any non-trivial constraints. But it is allowed to just replace some unification variables with empty records. That's fine. Or empty variants, I guess. Not empty records. So yeah, that's okay. So yeah, this can just do everything it did, and then returns the list of errors. Actually, it doesn't need to be resolved. I can just return the list of errors directly. Okay, and so functions this type check top level needs to return a type fashion list. That's the wrong order. Type check top level returns list. Oh, actually, it should return a difference list or something, because I'm gonna need to concatenate those. Right, so that returns a difference list, and now type check. Yeah, maps. Why is that? Why is that wrong? Right, yeah, now I need to actually split those up. You can tell it's old because I used a single letter variable name. Yeah, and errors. And I just accumulate the errors. Let's append. No, right, that's first new errors and end that. That and list. Okay, perfect. So this should return global and errors. And I can just return the errors here and change the interface file. And now this, well, this might still throw type error right now, but I'm gonna get rid of that. And something is wrong. Oh. Also need to select the expression, of course. And I did not do that correctly. Oh, because it's a difference list, not a list. Oh, sure. Well, I guess it could return a list. You can just force that, that's fine. No, driver's confused. And yeah, I'm gonna need to figure out how to print those. That's really annoying because I moved the printing logic. Yeah, I guess I can just bubble them up again. Because the printing logic is basically not part of the actual, like, Polaris as a library. That's only in the actual executable. So that the language server can use its own logic. Or I mean, like, it calls into the executable to get error messages here, so that the language server can share the same messages, but the way they actually display it is different, of course. So I need to return those. What's error.t? Oh, wait, actually return an error.t here. Oh no, as a result, either that or an error.t. I guess I can just type errors here in the end. Something's very confused. Errors. Okay. Right. Yeah, okay, cool. Wait, that worked? That's it? Alright, and I need to return those here as well. No. Here. God, like, the number of things this function returns is so annoying. Alright, and I don't want to do that. Yeah, I want to return this one as well. Okay. So now I've got a whole bunch of interfaces to update. Yeah, so run. And run. Yeah, no, run also returns something. I don't think I actually use that anymore. Might be able to get rid of that later. Yeah, I don't think I use this function at all to just run in some code and return a single value. Yeah, no. Okay. Might be useful as a library though. So, a list of errors, and it's also going to return a list of errors, and this one's going to return a list of errors. Okay, perfect. And now main. Let's keep track of type errors. Wait, why does that's not how that's supposed to work? Oh no, that's wrong. That's very wrong. Oh no. Oh no, that's yeah, no. Parsing and type check returns that as just a regular return, but yeah, running should fail. Yeah, okay. Running should fail if there's an error, and not just continue running and then return the type error afterwards. That's, yeah, no. So I guess this just returns a list of errors in that case. There's an error, and in the other case, it right here if yeah, type errors is an empty list, then it continues on, and otherwise it's gonna return error. And this is very unhappy. Why are you unhappy? This expression is type error.t list, right? And it's expected error.t, that's wrong. So that's the wrong kind of error. I'm not sure what it's about. The error is generic enough. Is it? Yeah, no, that's fine. Very dangerous. That's not enough. I should change that. Blocklist. What did I do here? This locations? What? No, that's. That's right. No, it's not it. What did I do here? Yeah, no, that's wrong. Not sure where that comes from. Yeah, I know it's meant to return error list, but it's only returning 1. But why is it only returning 1? Here. No, it's supposed to return list of errors. Huh? Okay. I need type signatures, and yeah, that's why OCaml should have bidirectional type insurance, because in that case I would get a much more meaningful error message here. Because I genuinely don't know what I did wrong. Handler errors takes a handler and an A. Yeah, and that returns an something or error t list result, right? No? Well, it scopes the wrong way. Yeah, that's correct. And if that's what this one returns, then the other one has to return the same type, so this has to be a list. Error of lists, what? This one only returns OK. I'm slightly confused. Why does... Okay. I love OCaml's type errors. Oh, no, it's not because I did the thing wrong here. Oh, because I used let star and this returns 1 error, right? Yeah. Okay, that's all there's to it. Oh wow, that's okay. That's such a terrible error message, because the actual error is here, and if OCaml had bidirectional type insurance, it would have figured out that I can't use let star on this thing here. There's a list of thing written or something, right? What's it called? I don't remember what it's called. Oops. And that's right. Yeah. And now it just compiles. You know it's bad when you miss Haskell's error messages? Okay, yeah, this one doesn't return type errors, this one just does that. And then this list. What? Value and this. Oh. Hmm? So result is a value and an environment and scope and a global environment and a list of errors. Yeah, that's correct. Oh. Gotcha. And now this would compile if it updated the interface file. Really shouldn't use lists everywhere. That's something I'm gonna have to work on at some point. Like, singly linked lists are such a bad data structure. We still use it everywhere. Yeah. Okay, what's wrong? Run. Yeah. Missed that one. And this one is the wrong one. This one should actually carry errors like this. Okay, perfect. So the driver compiles and this one does a run, so it what? This one? Oh, I'm doing fatal error for handle errors. Actually, that's fine. I can just change this one here. Oh, that's how I did that. Oh, that's really. Why did I do that? Oh, okay. Let's comment that out for now. I need to get back to this one. Where does this exit? Shouldn't. Like, this whole thing should exit anyway. Oh, is that, that's about, oh, I know what that's about. That's an ugly way to do that. Why did it do it like that? This is about, the REPL. Like, if you interactively run a script, then you need to exit if you can't pass command line arguments. No, that doesn't make sense. I don't know what that's about. I need to look into that. But I guess actually this should be relatively straightforward to do. Believe it or not. If we just do this for every single arrow. Wow, that did not expect that to be this easy. And this one doesn't return type errors anymore. That's not the issue. Error T-list, yeah, that's correct. Unit, oh. Something is missing. Oh, because this returns listed iter. So returns. Oh, because this one needs to return A. This one needs to fail. Okay. Oh, right, and then no, that Okay, this is really weirdly written. I don't know why I wrote it like that, but handle errors takes a function that needs to exit. Like it needs to take a function that returns for all A. I'm not sure I did that. Seriously, why did I do that? I don't want to do that. So I guess I can't actually do it like this. Guess I need to tell it how to return like this. Yeah, so if I can produce like a dummy value, that's also fine. Sure. This one shouldn't run fatal error. Yeah, it's just this exit one. I can just remove that. And I guess rename that because it's not actually fatal anymore. And some exit I just exit with an exit code of 1. And why is this syntax error? Oh, that because I missed a semicolon. Right. So this needs to be print error. And oh right, that's in the wrapper? Oh no, that's the initial execution, yeah, right. And so there I can do what is it? No, it's not. Yes it is. Oh yeah, yes it is. Okay, so I can just exit 1 in that case. Here, right, this one recurses infinitely, that's why I did that. And that's fine, I can do that. This one's wrapper error. And then recursion. And assertion failed. Oh, right. Okay, cool. But that's annoying because it means I can't actually see what I was trying to see. But yeah, that's fine, right? Because I have no idea how to do that. Missing instance EQA, perfect. And so if we have a second one, I guess, wait, no, missing instance EQA, oh no, that's wrong. Oh no, that's not the expected error. I messed something up. Completely. Do any of the tests still pass? Oh, no, because the language server doesn't compile. Yeah. Let's do that later. Okay, so I messed something up. Okay, so do I already have any traces? It's called class. Okay, so it's checking EQA versus EQA. Alright, yeah, it's checking EQA versus for EQA the scolum. Oh no, this one's wrong. This is the one. It's checking EQ scolum A versus EQ scolum A and failing for some reason. And why are you failing? Because this finds a scolum and then matches that against another scolum, and that should work. Does this even run? Does it even get to this, or does it get stuck earlier? Oh, it does. It very much does. That's weird. What? Oh, wait, is it because I'm not matching the type correctly? So I'm not following unification variables. Huh. Okay, that's why. Okay. So I'm not going crazy, I just forgot to actually deal with unification variables correctly. And that's why functional logic languages are pretty cool. As Gabby should know. Yeah, okay, so this one works correctly now. Perfect. Yeah, so that's cool. And if I actually cause a real error, for example, if I try to write the same thing but without an actual constraint, then it creates an error. And if I don't know, try to add that to something else, then I still only get one error. Oh, because it's unification. Yeah. Unification doesn't actually take the path yet. And now create second error. Then no, I only get one. Huh. Oh no, because 5 has an instance. So I try like true. Yeah, no, it creates two type errors. Perfect. Wow, that was easier than expected. Cool. Okay, so I guess I can commit that. Yeah. Right. And right, so now we can do right, we have two choices basically. We can either do like actual error messages, like that error messages are accumulated correctly and don't like multiple errors build up like they do with type errors or with constraint solver errors, so that yeah, unification doesn't fail but just or doesn't throw an exception but just adds an unsolvable constraint. Or I guess it's more interesting if we go for type class entailment. I always forget that name. So entailment is if you have an instance like EQ, like for all A, Claire came up with that syntax, EQA to EQ list of A, something like this, right? Then if we resolve an EQ list of A constraint, that entails a new constraint for EQ of A. Right, so if you resolve, like if you have wanted for EQ list of number, then that is processed by turning that into a new constraint for EQ of number. And then we're gonna solve that one recursively, or try to solve that one anyway. Yeah, that shouldn't be too difficult. Although we do need to modify the parser. Yeah, right. That should be straightforward enough. Right. So, instance, right. So an instance takes the name of the type list, but now it should also be able to take one or list of, yeah, no, one, no, no, it should take a name list and a entailed constraint, or no, I don't know what those are called. Yeah, so that's just a type, and I don't have a kind system just yet because I've procrastinated on that one for a year, but I'm gonna have one at some point. And now I need to modify all of those. Oh wait, no, that's just spaces. Although, actually, no, that should be a list. We take super constraints. Should it? I guess it could just be an empty, like, entailment tuple, but that's easier this way. Yeah, let's just do that. Yeah. String concat, not just a concat, of course. And the traverse line needs to traverse all of those. Because of course it does. Wait. Oh, those are. Those are not parameters. Are they? Those are arguments. Yeah, those aren't parameters. Oops. Okay, and now the traversal is fine again, so we can actually do okay, so the eval doesn't actually care. Shouldn't care about the arguments either. And yeah, we're gonna need to modify the parser. Oh, wrong one. I guess it's aren't really parameters, are they? They're more like universally quantified variables. I guess in somewhere they're arguments. Ah, they're parameters. Oh, and I need to rename those. Yeah. Oh, yeah, actually need to do something interesting here. But that's fine. Renaming arguments there. Alright, yeah, but I need to get the parameters in the scope first, but that's fine, that's easy. Okay. Insert type, oh, that's the one. Did I just have a rename? Let's rename type to that. So I guess I can do entailment first. So that just does rename type, location, entailed, scope, entailed, and that should be that. I guess we'll just do that manually. I do have an insert type, I think. Oh, but just inserts, it doesn't actually do anything interesting. Okay. So I guess, okay. Wait, how does rename type do that? Wait, no, in for, not in thing. Oh, that actually does something kind of interesting. But yeah, no, I can just do this thing. We can just fold map this thing over the parameters, and that should be it. With current scope as starting point, of course. Yeah. Cool. Hey, I'm good. I'm working on type classes, if you couldn't tell. So yeah, we just made type classes actually run for a change. So this already all compiles. Well, not right now because I'm changing things, but this compiles perfectly, and we're doing entailment now. So like, if you have an instance for equality for lists of things, then in order for that you need an equality on the elements of the list. And so if you have an EQ list of a constraint, that entails an EQ a constraint. And that's actually pretty straightforward in the constraint solver. Just kind of a lot of plumbing around to get those instances to actually work correctly. So that's what we're doing right now. Yeah, it's that's pretty cool. It's like if you know Haskell, it's pretty similar types of system-wise. Yeah, especially around like type classes are very similar to the way they work in Haskell. Yeah. Yeah, but this right now is just the renamer, so that yeah, it's just boilerplate mostly. Why you'd use type classes in Polaris, you mean? Because they're extremely useful. Because type classes are great. They're especially like Polaris has. So one of the defining things in Polaris is you can do things like program calls. You can do like ls, and that will give you the result of ls. And like the arguments to a program call can either be a string, or they can be a list of strings, or they can be a number, or list of numbers, or something like that. Or not on this branch, but on another branch I'm working on, functions. That's pretty exciting. Yeah, but that means you'll need some way to like quantify over the type of the argument, and that's currently like an ad hoc type checker constraint, but I'm gonna replace that with type classes. That's a pretty cool use case. Among everything else you can do with type classes. Yeah, it's pretty fun. Yeah, but for that we'll need to get entailment working first. So I can never remember the order of arguments. Right. So add type variable, or add the variable to the scope, and actually return the remaining thing. Perfect. I don't have a job. So yeah, not really that interesting. But I guess if I were to do this professionally, which would be pretty cool, it would be like compiler engineer or something. So if, I don't know, someone wants to hire me. Yeah. Right, okay. So what's wrong with entailed? Right, because renaming things also returns renaming types also returns environment transformer, which I don't think I actually want anymore, but I'm gonna need to figure that out. I think you overestimate how old I am. So I'm gonna do my undergrads in October. So yeah, full-time student for now. Yeah, but wait, no, you no, I lost my train of thought. Why does this not compile? First type the type. Profit from Facebook. I don't know who or what that is. Sorry. No, it's just because my display name is Profit. So it's Profit Devs. You know, nothing too fancy. Why is this? What's wrong here? It's expected type pass. Oh, wait. Because I'm an idiot and I'm putting it on the wrong side. Right. That's better. Okay, cool. So the rename is done. We need to modify the parser now and hope that works on the first try. So these are gonna be just empty list. And oh, that already compiled. Cool. Alternatively, yeah, I don't have donations. This is my second stream actually, so don't worry about it. But thanks for the offer. So I guess it's this, and then Why do I? No wait, it's not 4, it's 400, that's fine, yeah. So it's, what's the thing called? Do I have many? Is it called many? I don't remember. So for all thingy, type fat arrow, and then the same thing is up there. I think, yeah, that's so hard to read sometimes. Right, and the rest is pretty much identical, except that all the numbers are off. 4, 6. Oh no, that's one type. Oh, that needs to be. Oh, cool. That's starting a job. Well then, good luck, I guess. 6. 10, 12, 13. Hope I actually counted those correctly. In another case, for more than one constraint. Does this need to be 1? It doesn't. Oh, does it? Yeah. I guess it should be trading. And now all the indices off again. Seven, then this is 9, this is 11, this one is 14. Okay. And that's wrong. Why should I not make this a lowercase thing? Should really be lowercase. Ident is undefined. What is it called then? It's not called ident? Oh, it's, yeah, it is, but it's uppercase ident. Right. That makes more sense. Many is undefined, so I don't have many. Okay. No, that's some, not many. Nothing, or it's actually, no, I shouldn't do that left recursively. I guess I should, and then reverse. Yeah, that's fine. Because shift reduce passes are faster if you do left recursion, right? Type unit, so I messed up the index. 4, correct? 5, 6, 7, correct? 8, 9, 10. Alright, these are all of one more because of the closing parentheses. Hey, and the parser works. Perfect. Let's call this universals because that's weird. Oh, I actually need to do entailment. Wait, how do I do entailment? Do I just add that to given? I guess I just keep track of that in the given. Wait, so wait. So if you have let's just draw that. So if you have I don't know, given you list A, and that will always entail to your A. I don't. Sorry. Is there a way to get? How does that work? If you have like GADTs, is there a way to get it? No, if you have dictionary, then you already have the constraint. This is only for top level constraints. So I don't technically need to store it in the given. Should I? Yeah, I don't know. I'm really unsure about that. I guess I should put that in the given, but it's kind of weird because it can't happen for local constraints. So like local assumptions, that can only happen for top level instances. So I'm not sure. Yeah, I don't know. What's this one about? I don't remember what that's about. So I guess I guess it's pretty straightforward. I guess we just really do just add that to the given constraint. Given has given class constraint and a list of entailed. Wait, those are wanteds though. Wait. Those entail right. Those entail any kind of type constraints. Because you might also have equalities in there, like with functional dependencies. No, that's fine. I think I'm gonna draw it like that. I think so. Anyway. So where do I construct the given? Where do I construct the given? Unit givens? Oh, that's that constructs the given. Okay, so that needs to just take a list of entailed constraints. And the evidence, although I'm gonna construct the evidence. How's that gonna work? Oh, that's weird. Oh, that's really weird. Yeah, not sure about that one. I'm gonna have to think about that one. Right. What's wrong here? What's this transform from? Oh, unit givens needs to take the right, and this one gives a given, so this one no. Givens given How do givens entail things? How does that work? No, givens don't entail things. This given, like givens from a constraint, local givens, basically don't entail things. I think. Hope that's correct. And oh god, imports. I'm not gonna worry about that one for now. Hey. Okay, where was I? Right, givens. So these, where's that one from? Let instance, right. So instance declaration is actually to the sanctions, yeah. Wait, those entailed ones are types, so I need to extract the constraints from that route. I have a function for that, I think. Although this source thing is wrong. This doesn't, like if there are entailed constraints, then I need to, then the evidence needs to be a function that can be constructed. Alright, bye bye. Yeah, like the evidence needs to be constructed from, like, right, then like in this case, the evidence is just a variable basically. Like, if there are no entailed constraints, if you have something like instance EQ number, and that basically desugars to like a dictionary for EQ number. That's just a variable. But if you have something like instance EQA, or for all A, EQA and EQ list of A, then this is going to desugar to, like, I don't know, all A EQ list A, which is a function that takes like a dictionary for EQA and constructs something from that. And that's problematic. That's, oh god, that makes things much more complicated. What's the thing called for given constraints? Like collect atomic wanted wanted? Do I have that for givens? Collect atomic given constraints. Yeah, I do. That's nice. Atomic given constraints and entailed. Something else? Class constraint, evidence source list, source list. Yeah, okay. Does that need to return evidence like that? I guess it does. Oh, and then the given also needs to... Wait, I did something for evidence. I think I can reuse that. I hope so. Anyway. Yeah, I don't know. Need to figure that out. That's the list of tabs now. Yeah, so I need to flatten that back down again. You know what? Let's not use the list there. Let's just remove that and go back to changing everything. Why are there this many warnings now. What happened? This really pretty. Oh, that's annoying. Oh, I need to think for allowing unused things in kernel. How do you disable that on a module level? It's a thing, right? Hope so anyway. Because like the syntax module is completely magical. Like to get trees that grow working correctly. Yeah, there's some really bad magic in there. Yeah, I wouldn't write it that way again if I were to rewrite plus now. I don't know what it's called anyway. Or how to disable that on module level. That's entailed. Ah, right. And in this case, I need that one to be something. I'm gonna comment that out for now because that needs to be an empty shit, that needs to be an empty constraint, and I don't have those yet. I was actually trying to avoid doing that now, but I guess I need to. Oh, no, that's why. I guess, okay, I'm just gonna use, no, I can, could use unit. I'm gonna use an empty, yeah, I'm just gonna use type level tuples, that's fine. Is it? It's gonna break once I do kinds, but that's fine. Oh, that's gonna panic. It's gonna panic so hard, but sure. So those are entailed constraints? No, those are... does that need to keep track of the evidence? I think... No, I don't think it does. No, no, wait, those are class constraints and evidence. Right, so I need to create... I need this one to also return actually given constraint thing, so entailed constraint. Except I don't. No, I don't, because this one can't actually produce any. Right. Just if this is a closed, not record, empty tuple, which is not unit. Unit is not an empty tuple in Polaris for very interesting reasons. And this is just going to be an empty list and another empty list. It's just going to be an empty list and another empty list. And I guess this one is also going to do the same thing. Right. Just have string list. There's no constructor to prevent list. What? Oh, wrong one. It's better. As partial. How's this partial? Oh, because emit givens needs to take a list of. No, what? Givens are. No, that's not how that should work. Should take the entailed from the given constraint itself. Yeah, that makes more sense. That's a class constraint. And evidence and no entailment. What? Tails. And I guess I need to actually print those. Yeah, sure. So it needs to take the entailed constraints, draw a carry pointer to their entailed parent. I'm not going to display those. Or do I? I guess I need to pretty tight constraint then. Yeah, I guess I can't really get around printing that if I want to have usable diagnostics here. So, sure. Right, so we can have unification, or we can have unwrapped program arguments which fine variants which should not be able to be created here. Interpolatable and wanted, which is the interesting one. Yeah. Actually, it's not used that arrow here, because I'm already using that for entailment. So unwrap, program argument. And right, refine variants. I guess I don't really need to print that in detail, because it's never gonna come up anyway. And finally, the actually interesting one, which is a wanted class constraint. And I only need the actual wanted constraint from that. Also the class constraint from that. That's not called wanted class, it's called wanted. So it's called wanted. Try that one. Yeah, alright, I need everything. Right, so that's on the universals, and then those name, oh, right. Variables, and then the actual constraint. And I can't spell class name apparently. Okay, so that's that done. Took way too long for something this simple. But sure. Wait, why can wanteds have wanteds counter forwards? Oh, I really need to change that. I desperately need to change that. Not here, because it's gonna break too much stuff, but gonna change that eventually. Right, that's wrong now. Instead, this. I guess this does need to. Should return. Okay. Right. Okay, cool. So this compiles. That's good. This doesn't. Because right. State constraints and evidence. And I don't know what to do about the evidence. Sorry. I don't know what to do with that yet. Why is this not compiled? Oh, because entailment constraints are class constraints. And so I need to construct wanted constraint from this, but oh, but I don't have all the metadata for wanteds. Do I? Yes, I do. Do I? What do I need? Oh, actually, no, I need what? Wanted class just type class constraint? No, it's not. No, it's not. Here. So I need location. I need actual wanted, I need givens. Oh, yeah, or givens, that's fine. Is it? Maybe. I need the environment. Oh god, where do I, can I? Ooh. Oh, that's problematic. Can I do that? Can just take the environment. And I need an evidence target, which I have. Okay, so I can just take the evidence target. And I can take the wanted. And I can use the location. Yeah, that's fine. I hope. No, that's wrong. No. I don't want entailments to... No, I don't want entailments to return full constraints. Like type constraints. That's wrong. No. These should be... These should be just class constraints. And maybe some evidence. Probably. Maybe? Yeah, probably. But now I also need to... Wait, how does that work? No. Yeah, that's fine. Right. So I'm not going to create a one constraint because I don't know the details of that one yet. Like the environment and the givens. So I just want to create class constraints. And now I can change everything again. Great. And I don't think entailment gives me any evidence yet. Or it shouldn't. I guess it does, but I'm not sure what that means. And now Okana is freaking out completely. Why? Because yeah, right, because givens don't... No, givens are correct now. What type class constraint evidence, type constraint list? Class constraint... Oh, right, no. That's class constraint. Evidence and class constraint list. Okay, so... Oh, right, because I'm pretty printing. I just want to print a class constraint, which I apparently don't have anything for yet. Yeah. And how did I do that? No, that's correct. Oh no, it's what's the thing called? Type definition. No, it's not called type definition. Where do I pre-print types? Yeah, right, it's print type, and that's somewhere else. Okay. I can actually type here, and that works. Right, back on track. So that's correct. What's wrong here? Class constraint evidence, class constraint list. Evidence? Wait, evidence, yeah. And a list of class constraints. Why does it want a list of class constraints? Oh, right, yeah, no, it does. Those are... No, those are... I don't need those anywhere else. I have those from the given already. So just given that entailed. Ah, that's why. No? They're not. No, because it's a class okay, now I'm confused. Actually did that already. I know. I'm gonna be right back. And I'm back. Okay, right, where was I? Right, init givens, how does that take entailment into account? Yeah, it should take that in the given, yeah, right. It should take an entailed. And now here, source, and oh right, that's different, doesn't exist anymore. That's fine. Okay, cool. Works, and this does not. For arguments, it didn't fix that one earlier. Oh, that's exports. Oh, that's annoying. Right. No type definitions don't match. Right, because it changed givens. Because this one also takes entailment now. Pass error. What's the pass error? Did I? Oh, I forgot one pair of parentheses. Or one single parenthesis. Yeah, that's the one. And now all the indices are off. Or well, one index is off. And that was not it. Huh? Where was that not the issue? For all a dot eqa arrow. Oh, does that pass as a constraint? Oh, that would be terrible if it did. Yeah. I hope it's not. Let's try to limit that to parentheses for now. Yeah. And now the positions off again. It's 4, so it's 7, that's 10, yeah, 12, and yeah, 16. Hey, first try. Pass error. Right, yeah, that's correct now, because I changed that. So this is now... Huh, that's... Oh, that's good. Ooh, I can try some polymorphic recursion. Okay, does that compile? No, it panics. Great. Where does it panic? Uninstantiated type variable found during unification. Oh no. How did... Okay, let's move this to its own test case. Because that's a lot. Let's start with something simpler. Right, and we have an EQ number instance, just because we need something to test this with. Right, okay, so we have that factor out to test case, and that's correct. That's good. Is it? Yeah, that's correct. But that's not entailment. So, let's just ignore the implementation for now. And oh, that compiles. That's good. Wait, I'm not using entailment anyway yet. When solving constraints. Right, because this one also needs to find entailed. And then here. So in this case, okay. Oh, I have an idea how we can do evidence now. Because like I was just filling that immediately with the source, and I guess now I need to entail the like solve the entailed constraints, although those might not be solved immediately. So and create new targets for those. Actually, that might just work. Yeah, but I'm not sure what evidence yet. No, I'm gonna have to do it now. So, oh, this has to be recursive. Right, and so, okay. Right, this returns a boolean if it's made progress, but I don't care because this one has made progress anyway. Why does this return some unit? What? Oh, because I'm using find map? Why am I using find map and unit and just find and booleans? I'm not sure about that. Why is this? Why does it want this to be given constraint now? What? Oh, Camel's error messages are so bad sometimes. Oh, because this is so find opt. Ah, and so I guess no, wait, we just need to exist. And I guess that one will create all the constraints and stuff, so it's fine. Yeah, sure. Let's stick with that for now. So I can just iter here because I don't care about the result. Yeah, I don't care if those made progress immediately because this thing has definitely made progress. Yeah, right. I just need to find out if any one of those have matched. I think I could do that a bit better. Right, so if I have an entailed constraint, then I'm going to create evidence for that. Well, I guess I need the evidence somehow. Well, I'm gonna need it anyway. Oh, I guess I can do like an evidence pipe kind of thing. But that's just a like a more or less unification variable that's then later filled in. Something like that. Guess that's gonna work. Yeah, I think I can do that. Yeah, but for now this is gonna be an empty target. Right, so this has an evidence target. And it's going to try to, anyway, solve a wanted class constraint with the same location. You can just carry this one, that's not called local. It's called wanted location. And the same unifier state, because that hasn't changed. And now the constraint is the entailed constraint. And the givens should be unchanged. Are they? Can solving one constraint create new givens? I don't think it can. I think it can only create wanteds. Yeah. Yeah, solving constraint can create givens. I hope. Anyway. The local environment and the target. And I don't care about the progress, and I'm going to return this evidence. And that doesn't work. I messed up the order somewhere. What? Takes 3 class. What? Environment, unifier state wanted, givens local environment, and an evidence target. Location, unifier environment. Right. That's better. Then it creates entailed evidence, which I'm not entirely sure what to do with yet. And that seems fine. Oh, I actually just realized I used the wrong equality thing there. I need to use EQ, not the operator, because that's just structural equality for now. Missing instance EQA. Oh, that's bad. That didn't instantiate the thing correctly. Oh. Oh? Right, I need to... Huh. I need to actually use the substitution here on the entailed constraints. So is valid instance shouldn't just return a boolean. It should return a substitution. And I can unwrap that because I'm not going to need to modify it again. Right, and in that case, yeah, I need to apply the substitution. Okay, yeah, right, so we I need another traversal. Just traverse type. And I don't care about the state. Yeah, right. I need to actually find the traversal now. Okay, so substitution, traversal. And I'm gonna need a case for variables in records and variants, or two cases I guess, but I'm not gonna worry about those yet, because those are kind of weird. So what's wrong? Effective Tyler, right. That's just a name. And something else, it's not anything, and record variables and parent variables I'm gonna worry about later. Adopt. Oops. And yeah, it's returning that or not. What's wrong? Unit 2. It's expected to have, God. Syntax error. Oh. Forgot the vertical bar is. I've been writing way too much Haskell. So that's a constraint. Oh, whoops, that, that's not supposed to traverse the type itself, but only the arguments. Expression is type A list with an expression is expression of type. What? Oh, because I need to. What's the list? Something? Yeah, right. Entailed is entailed with arguments equals entailed arguments in. And I misspelled progress. Great. Okay, cool. Why did that print true? Oh, did that just work? Let's try that with something else. We need true false. This is gonna print missing instance equal. And if I use numbers, it just works. Wow. Okay, that's pretty cool. If I try that on this one, it probably won't work, right? Yeah, it still crashes with uninstantiated type variable. I don't know what that's about. But yeah, right. So we got this part working. So guess I'm gonna end the stream here. Yeah, entailment is working correctly. Evidence still isn't quite there. Yeah, but we've got most of it. It was a fun stream. See you next time, maybe, hopefully. And until then, bye bye.